In this video, I want to go through a CFA Level 1 exam style question on computing sample variance. One of the more technical things or quantitatively engaging things you may need to do in the exam. I want to show you the formula for doing this sort of in the old-fashioned way, but also how your Texas Instruments calculator can do this relatively quickly and easily for you as well. So if this is something you want to get right, keep watching and let's get solving. This is the question which I want us to have a go at. The table below provides the annual total returns for 5 individual client portfolios managed by Sunrise Capital over the past year. And you may have seen this data before if you watched the video on mean, absolute deviation, and range. This time we're asked, what is the sample variance of the portfolio? Okay, now the variance and its sidekick, that standard deviation, are some of the most widely used measures of dispersion. So how dispersed a data set or observations are, how dispersed around their mean or arithmetic average they are. And the formula for sample variance, which you'll kind of need to appreciate, is as follows. Well, first of all, we often denoted as S squared. And this is going to be the sum of all the deviations of each individual observation from its mean or the mean value of this data set, but squared divided by n minus 1. The reason why we start with observation number 1 and we finish obviously with observation n. Now, the reason why we are squaring here is that if you simply were to add the total of all the deviations from the mean, you'd get a value of 0. With MAD, mean absolute deviation, we put those straight lines around these so as to make them absolute, ignoring the negative sign and the plus, and making everything positive. Here, the solution is to square everything, and that way avoid a numerator which would come in at 0. Now, just like I did in the previous question, the first thing I need to do here as well is simply to calculate the average or the arithmetic average. So that's going to be 2 plus 3.5 minus 0.5 plus 0.3 minus 2.6. Add this up, divide by 5, the number of observations. So that's our n, essentially, the 5. And let's see what this gives on the calculator. So 2 plus 3.5 minus 0.5 plus 0.3 minus 2.6, divide this by 5 equals 0.54%. Brilliant. We've got the mean. Now, let's measure the square of the deviations, or the deviation squared, add them up and divide by n minus 1, which will essentially get us to the variance. Taking each observation sort of one by one. Let's start with the 2. So first portfolio was 2 minus 0.54, but this time square it and record the subtotal. So 2 minus 0.54 square. Okay, this is going to give 2.1316. And please note that because this was all in percentages and we're squaring the result, the resulting figure is going to be in rather awkward units, percentages squared. The next one is 3.5% minus the same mean, which is 0.54%. Okay, because this will appear consistently sort of in this column, more or less, if I manage to get things straight over here. 3.5 minus 0.54, okay, square the result. This is 8.7616, once again in percent squared, or percentages squared. Third one, 0.3% minus 0.54%, square this. So 0.3 minus 0.54 square it. Oh, sorry, I omitted one, didn't I? But I'm going to put this in here. It doesn't really matter what order I do it. So I managed to omit one, but I'll get back to it in just a moment. So this one is 0.0576. And now for this one, so it's a negative 0.5 minus 0.54% square the deviation difference. Okay, this is squared 1.0816% squared. And the final one, that's the fifth one, negative 2.6. And okay, this is obviously in percent, so minus 0.54% square this. 2.6 negative minus 0.54 squared. Okay, this is the big one. It's 9.8596. Please appreciate that without this squaring over here, if we didn't square everything and we just added up these differences, which are expressed in the brackets, we would get a total of 0. That's the property, essential property of the arithmetic mean. Now we need to add these up. So essentially, to get to what is being required here with the sum of all these squared deviations, let's add them up, see what we get. So I've got 9.8596 on my calculator. So I'm going to work my way from bottom to top here, plus 1.0816. Next one, 0.0576 plus 8.7616 and 2.1316. Hopefully I got that right. As you can see, there's lots of room here to make an error, potentially, when you're adding these numbers up and obviously previously calculating them, but the sum is 21.892, and this is obviously expressed in percent or percentages squared. The final thing we need to do to actually make it or turn this into a sample variance, so S squared, is we've got the top of the fraction, the numerator, 21.892% squared. Let's now divide by n minus 1, which is basically 5 minus 1, or 4. The reason why we don't deduct by 5, but by 5 minus 1 is because we're dealing with a sample here, and when that is the assumption which your curriculum generally wants you to make nowadays, this will give a better approximation of a result which has more predictive power for making certain conclusions about how this portfolio manager may behave in the future. Don't worry about this. Let's divide by 4. Okay, as you can see, the result is 5.473. And this is, once again, let me stress, expressed as percentages squared. And it corresponds, doesn't it, with answer, perfectly corresponds with answer A. Okay, good. We've got the result. Now, first of all, let me just say that dealing with a metric which is expressed in percentages squared or units squared, this could be centimeters, percentages, I don't know, kilograms, whatever, squared, is difficult. It's difficult to draw conclusions from something that's expressed as units squared. So what typically happens in finance and generally in statistics is we turn this into a much more manageable figure called standard deviation, which is basically the square root of this, and that standard deviation is going to be expressed as, or in this case, as percentages, not percentages squared. So if you want to turn this into a standard deviation, you just, you do S squared square root, and standard deviation for a sample is denoted by the letter S. Okay, that's not part of the question, but I needed to know that. Second of all, if you're asked in the exam to do this type of computation, which I don't think is very likely because it's more probable that you'll need to use a standard deviation measure provided. However, if you have to, this is time consuming and there is plenty of room to make an error. So fortunately, your Texas Instruments calculator has an easy, well, relatively easy solution to the problem, because you can use two of its functions or worksheet called the stat and data worksheets, which we can use to get the calculator to compute this stuff for us. So let's have a look at how this works. Okay, I've got my calculator, as you can see. Now, we will go and press a button called data, or let's say we'll go into a menu called data, and you will see that data is accessed by pressing second followed by 7, because it's the secondary function of the 7 key. So press second 7, and you should now be in the habit of clearing your worksheet when you start working with them. So just like with, for example, the CF worksheet or anything else, press second followed by CE stroke C, which is the key on the bottom, so in the bottom left hand corner of your calculator keys. It's got clear work or clear worksheet as its secondary function. Press that to clear any data which may be sitting there. And this is the place where you simply enter the sort of the raw numbers from the data set, all the observations, which are 2, 3.5, 0, 3, minus 0.5, and minus 2.6. It doesn't matter what order you enter them in. It's going to generally be fine. And look, for x01, I'm going to press second followed by enter. Equals sign appears, meaning my calculator has now accepted the relevant input. Press the down arrow. It allows you to input a value for y. If we were computing something like covariance, so the degree of co-movement between two variables, we would have a y. Just think about this like x being one set of data and y another set of data, as if you were doing a graph and you had the x-axis and y-axis. We have nothing for y. We're just going to input a series of x's. So x02, I've pressed the down arrow again. It shows me x02. What do you want to make this input? Well, I want to make it 3.5. So 3.5 followed by enter. That's accepted. Press the down arrow once, second time. Okay, x03, the place to input your third data point, which is 0.3. Follow this up with enter. Twice, the down arrow again. Now the negative 0.5, so 0.5 followed by the plus minus key over here. Enter again. And now for x05, that's 2.6. Once again, make it negative and press enter. The really nice thing about data, the data worksheet, is you can review your inputs with, go up with the up arrow, up down with the down arrow, just to scroll through these and check you've got your x's right and that you haven't input anything other than this default one for y's. I think this is okay. Now, just like with the CF worksheet, the cash flow worksheet, the data worksheet is just a place to store data, the raw data. It doesn't actually do any of the computations. The computations happen next door, which is in the stat worksheet. So to enter the stat, you need to press second followed by 8. Second followed by 8. Okay, and over here you see linear. Leave it as it is. Don't change that. Press the down arrow. Okay, and now it's spitting out some, relevant information. It's showing you, okay, I see that there are 5 observations next door in the data worksheet that you've entered. Good. That's confirmation that we've done it kind of correctly. Okay, then x bar. The arithmetic mean is 0.54, which is actually something we calculated ourselves as well. Brilliant. Okay, and now it's saying Sx equals 2.3394. Okay, and there's a little bit more there. Now, this is, look, the standard deviation which your calculator has computed. So this is the sample standard deviation, and it will not provide you with the variance, But we know that there is a very, very easy connection between standard deviation S and variance S squared. If you are asked for the variance, just take what your calculator is showing you here and press the x squared key, and you'll see, hey, 5.473, which is what we computed by using the sort of long method here and doing all the calculations ourselves. So easy solution. If in the exam you are asked for sample standard deviation or sample variance, just use the data and stat functionalities to get to the result. It will always show you the sample standard deviation, the S, but if you want to turn that into a variance, just raise it to the power of 2.